Welcome to Everything Distributed. Today we are going to talk about topic on peer-to-peer, or so-called P2P systems. And the content is partially based on this very nice survey on peer-to-peer content distributing technology, which was published by ACM 2004. P2P, the concept is actually very simple. Roughly speaking, is that every machine in the system has a similar role. No one is more important than the others, and then no one should have a more significantly more workload than the others. And then in contrast, most of the topics we have talk about is actually like centralized. It's about the cloud, about cluster, where like you have specific servers that store data or like serve some requests or run some applications, and then you have client basically that they have no responsibility. All they do is that they need to contact the server to retrieve something or to store some data. But in terms of peer-to-peer, it's very different. So that there's not really a notion for server. It's like kind of you have data that distributed among like different peers, different nodes, and some of the application well known as BitTorrent, and then especially like cryptocurrency. Most of them are based on peer-to-peer design. And then if you think about distributed robots, those are all like based on peer-to-peer design. And what are some reasons that we want to have a peer-to-peer thing? Is at first scalability. If you think about data center, if you think about tons of machine there, yes, there are lots of them, but actually it requires a huge effort to manage all those machines. And then if you count data center as a one kind of big thing, then worldwide, how many data centers are there? I mean, at once, maybe you will only touch a five or seven, but like for P2P systems, it's actually very different. It's like you may have like thousands of nodes. For example, if you look at Bitcoin, there are tons of miners right now. And then this is the scalability that we are looking at. And because of the scalability, you have like many participants, servers, or like replicas or clients. So that it should be like highly fault tolerant. And ideally, if like half of the server kind of crash or become like malicious, you should still be able to ensure that the certain function should be ensured and certain property should be ensured. And nowadays, that one very appealing thing for P2P is that this censorship, resistant anonymity, privacy. Because if you think about this like kind of cloud server model, you basically upload everything to say Google, to Amazon. They know your whole all of your history. But like for peer-to-peer, there's a certain way to hide your identity, then you don't really reveal like too much information. And then the fourth one is like similar to the scalability. Ideally, you want to distribute the workload to as many peers as possible, so that no one peer is that kind of the like the server inside cloud that's a very has a very high workload. And then lots of existing P2P design. If you think about it, it's very good for sharing resources. So that suppose I have a free disk storage, I can save a movie for you, or like I can save some music file, and I can also like if my CPU is free, I can also like share my computation resource for you. Yeah, and then that's a Actually, I think that's the motivation or the beginning point for peer-to-peer system is that if I have something extra, I have some idle resource, I can actually share it. And, but like for peer-to-peer system, actually, it's a very challenging to build a practical application. The first one is like bootstrapping, because how do I construct the network of the system? Because there's no central server like I can go say that hey, I want to join this system, but like you somehow need to a way to like coordinate everyone. Say that okay, now we should start doing something. And then the second one is that suppose that there's certain data, certain type of content that you want to share, then how do others find it? Because there's no really the server or Google said that okay, I want to search something, and then how to enable this kind of content, either distribution or content location. That's a major challenge. And then even if you can locate it, how do I ensure that the quality of service is stable, the data is actually the original one that I'm looking at? Then that's another challenge. And then yeah, so all of this issue kind of come down to the management issue. The first one is a churn, because for peer-to-peer system, you don't really have a control of participant. They can come and go. They can decide that okay, now today I want to join for 1 hour. Tomorrow I am going to join 10 hours. It's really hard to manage this kind of supply. And then for most of users, they might be selfish. They say that, hey, why do I need to follow the protocol? I only want to follow protocol if it's only beneficial to me. And then if like someone is like kind of malicious, and then for peer-to-peer system, we also need to deal with that. So there are lots of challenges, but like even nowadays we are still seeing that many exciting applications. I think one of the most famous ones called this maybe CT or CT. It's that they funded by Berkeley. It's that you can contribute or donate your idle CPU resource that you can help analyze the radio that we receive from outer space. And then the hope is that we can figure out some signal that aliens or ET that try to tell us. And then there are very many similar projects that's called voluntary computation, because you can donate your CPU cycle to do the computation. And I think like for CT, this one is already not continuing, but like for this folding one, actually is that they are still active. Then I believe that they are still attacking something like related to COVID. So if you want to contribute your free computation cycle, your CPU, yeah, feel free to do so. And then the early version of Skype is that actually based on P2P thing, and then file sharing, and then now of course the big thing is about cryptocurrency, and which we will talk about like in the future. So we have all this thing like for peer-to-peer thing. Then let me start with the most simple application, file sharing. The first well-known P2P system is called nabsir, and then actually it's by an 18-year-old college dropout, and he like coding. He just stayed up 60 hours straight. It's not surprising for young kid, but I cannot do that now. But what's cool thing is that he basically got all the structure for Napster and allow people to share a music file in a peer-to-peer fashion. And then this kind of the beginning for peer-to-peer file sharing system, and then it's a very big news for music, because that kind of all these like dirty legal battles, and then I rethink about like what's the foundation for music, and then all those legal right. It's a very interesting thing to follow. And now we are going to look at like what are some of the more popular file sharing system back then. So for Napster, actually the idea is very simple. It has a two-phase design. So it's not really a pure peer-to-peer system, but like that's a beginning. So the idea is that okay, they have some servers, Napster servers, and then basically here what it does is that it stores the list of songs. But like the server doesn't really store the songs, the music by itself, but we have tons of peers, and other places they are smaller, and then they have all the music. And then for the client, if you want to download something, first you go to the server, say hey, I want to download music, and suppose the music is stored in a peer 2, then you go to peer 2 to download the music. So concept is very simple, but like back then it's actually revolutionary. And of course that because of this issue is the servers they use the centralized server to do this kind of locating the content thing. So it might not be as scalable depending on like how many clients you are getting that. And then I think modern days, if you have one server that you want to handle maybe, I don't know, a million clients is still possible, but like back then, it's not actually that simple. And then if because of this server thing, the system also has a single point of failure. And then more complicated thing is this legal issue I mentioned. So actually, while loss is not really about the system, it's about this like copyright violation because that somehow this server enable people to get that illegal song or pirated stuff, and then the back then is called indirected infringement. Okay, so that there's a second generation. It's that called Nutella. It's that idea simple. It's that okay, I'm going to get rid of servers. Then what you do is that the client machines you need to search and retrieve data among themselves, but and the client somehow act also as a server. So what they mean by server is that you need to handle this kind of administration kind of message, not just like storing the data. So like the in the terminology is called server. So what they do is that the idea is that you have some overlay graph. Actually, let me clean everything. So that in terms of communication graph, it's a multi-hop thing because that's more efficient. You don't really need to know everyone that you are going to talk to. Okay. So some of the example like overlay graph or the communication graph looks like this. Okay. So for the peers, what you store is that you have like your own local music file. And then you also need to have a pointer, for example, for this guy, node number one. It also need to store the information for node number three, node number two, and node number three in order to contact them. Okay. So once you build this peer pointer or the table of neighbors, then you are able to draw this kind of overlay graph. And then what they do is that they use this graph to figure out where the content is. So when you send out the query, say that hey, who has a certain file M, then basically what it does is that to flood all the query requests. So for example, for this client, you want to find a music M, you will send out the query to everyone, say that hey, who has this query, who has this music M, and then it also need to set a TTL because you don't want to get to everyone if because it's too slow. So typically you only do a kind of local search. So maybe that you said okay, after 5 hop or 10 hop that I don't want to continue the search. And then because there might be cycle in the communication graph in the overlay graph, so that you only forward the same query at most once, exactly once. And then once you hit the query, so for example 34821, and then once that hey, actually I have the music M, so you reverse the graph, the path back to the server, say that hey, now let's say this is number four. Say, hey, no number four. You know what? You're lucky. Here's your music file. So it's a very ad hoc. But like as long as you have enough music files, and then the underlying overlay graph is well structured, it's not too difficult to find the data that you want. Okay. And then how do you maintain this finger table or like this the table of your neighbors? What do you do is that you have this ping pong mechanism, or that you so someone also call it that heartbeat message. So periodically you need to send a ping, say that hey, are you alive? Are you alive? And then if you are alive, you reply to one, say that hey, yes, it's called pong message. And then this way is that when everyone join or leave, you can still somehow maintain a relatively fresh view of your structure of your this overlay grid, so that when we do a query, it's possible to find the file that we want. But the issue is that this ping pong thing actually consumes lots of bandwidth, and then yeah, because I felt the peers are dynamic, then you want to ping pong more frequently to make sure that this overlay graph is like fresh, more recent, so that it's possible to send a message or deliver the message to the intended server. And then for this is that there are tons of large number of freeloaders that don't really contribute too much. They don't really store the music. They just want to download something. And then because of this query, when you do the flooding, even though it's like in a local sense, it still causes like tons of traffic. So the newer generation actually try to fix all of the problems. For example, like we can use cache or sampling. We don't need to do really this kind of pinpoint thing. And then there's also other technological failure detectors, and which we might talk about in the future. And then for BitTorrent or for email, there's some reputation mechanism, meaning that you need to contribute something in order to download it. And then now that enters the very interesting analysis of game theory to make sure that people follow the rule or like benefit others. And then the third one is that the reason that they need to do flooding is that this figure, the overlay graph, this red one, is actually not known to outside. Sorry, it's that not a prefix one. There's no good structure to follow, so you cannot use a fancy routing protocol to figure out what's the best way to find your resource. And then later on, there's a protocol or a series of protocol try to impose a structure on communication graph so that the query can be done more efficiently. Okay. And then yeah, there's also other version trying to combine the two between Nutella and nabsir, so that there's a notion of a super peers or super nodes, and then it's actually the underlying technology for Casa and Casa Lite, but like it's not really open source. Yeah. But I think right now it's also still a somewhat popular way of doing this P2P file sharing. Okay. Now the next topic is that okay. Now we talk about like how we use flooding and then how we use like this ping pong thing to do things. Then the question is like can we do it in a less ad hoc way? And then in terms of research or technology, what we care about is that we want to routing. We want to route the message to a certain place. We want to be able to communicate with others inside the system. And you can think about this problem as information propagation, and you want to retrieve some information, and some of the important like the metrics that we care about, like load balancing, meaning that how many messages you need to forward, how many peers you need to know, and then how many kind of ping pong message or heartbeat message you need to send. And of course, we also have fault tolerance, meaning that how many crash failure can we tolerate, or like what is the churn rate that we can tolerate, and also storage space, like how many things that you need to keep track of. And then when you do a message query, how many message you need to send. All those things are important metrics, both in theory and practice. And then one of the very fundamental protocol is called gossip protocol. The setup is actually very simple. I have a single source, and then source has some message that need to send to everyone. Okay. So suppose I have a source here, and then here it has certain neighbors. And what you do is that you don't want to do flooding. Flooding is that you have message and then you send to 1, 2, 3. But like for gossip, is that I only send to a small set of neighbors. For example, in this case, maybe I only send to this guy. and then this guy will send one message to the others, and then it will send it back to here. So that's a push protocol. And then I also have a pull protocol, meaning that every now and then I will ask others, say, hey, do you have new message? Do I have new message? And all those things. And I can also do a combination of push pull, so that uh, this kind of protocol has been proposed and analyzed for a very long time, but like there are still new problem that we or new property that we are studying on gossip recently. Yeah. It's very simple, but like fundamentally, it's very powerful. For example, cryptocurrency, especially Bitcoin, use gossip to communicate or to propagate the, the transaction or the block to others. And then if you think about virus propagation, actually it somehow follow this like gossip way, especially the push protocol. Yeah. So, and then the next one, I want to complete this kind of talk by the very powerful concept called DHT. So what's DHT? It's called distributed hash table. So what's distributed hash table? Let me remind you what hash table is. So basically, it's a very useful randomized data structure. You can insert an object, you can look up an object, and then delete object. And each object, you can think of it as a key value pair. You have keys and you have value. And for distributed hash table, DHT, basically you do this thing in a distributed setting. And then if you think about it, Napster, Nutella, Fast Track, they are all kind of DHT. Just that you store some music file, but like if you want to store arbitrary files, arbitrary objects, you can still do that. And then suppose you have a system with M peers, then what will be some performance that we really care about? The first one is memory, how many things you need to keep track of, and then look up latency, meaning that how far or like how long does it take for me to figure out where my content is, and also like if I want to do this, how many message do I need? And for nabsir, because it has a server thing, so that for all ends at the server, but the rest is very fast because for peers you don't really need to store it, and then look up you can directly contact the peer, and then for message you directly send to the peer. But for Nutella, it's much worse because it really depends on your overlay graph. Okay, and this will be an take-home exercise for you. Why Nutella is O N O N O N. Okay, and then this code is the most structured type of a peer-to-peer system, and then they can achieve like all this at log n, so which is a good trade-off in many of the applications. So what's the key idea, big idea behind DHT? The first thing is it's a structure overlay. So that you cannot just arbitrarily join a system. Once you join a system, you need to have a certain rule or certain procedure inside the system, so that you don't need to store too many things. And then the next one is that because of this structure overlay, the implication or the benefit is that you only store or you only need to communicate with a few neighbors. You don't need to communicate with tons of others. And then for DHT, it's similar to Nutella. You still need to maintain a routing table, or meaning a table of your neighbors. But because all this thing, they have a structure, so the routing table is not that huge. And then because it also has structure, you don't really need to ping others so frequently, say that, hey, are you alive? Or like, have you changed your position or all those things? And yeah, and then the big things for core particularly is that it use the idea of a consistent hashing to figure out the position of each file and position of each peers, so that it can achieve this login thing. So in the future, if we have time, I will talk about that in more detail what the code is. But right now, just remember what DHT is and then why the structure would help. Okay, so that's all I want to talk about today. So the concept between like P2P and cloud, and then also some of the example application system, what are the trade-off, and then two important concept in like gossip protocol for communication and DHT protocol to store data and to figure out where the data is. Okay, that's all. Thank you.